Number 9 is on concepts from exam 2's material, and it has to do with carboxylic acid derivatives and their reactivities. So I have a nice little trend over here for a question like this. But first, what was the question? The question was, select the order that has the following reactions, 1, 2, and 3, arranged correctly with respect to increasing rate of reaction with hydroxide at the carbonyl carbon. So they tell you you're reacting with OH-, but you're not using it as a base. They say it's reacting with the carbonyl carbon, which means in each example, you're attacking the C of the double bond O. So either of these two. So now I'm going to go to this trend list over here. The most reactive carboxylic acid derivative is an acyl halide, or in this case, as I drew it, an acyl chloride. The reason being, when that OH- comes in and attacks the carbonyl, and this swings up, you get that tetrahedral intermediate where it's OH and then O-, and this O- will always look to reform its double bond, and when it does, it has a really good leaving group, a chlorine. Chlorine is an excellent leaving group, so it's very willing to react because you can reform that double bond O very easily. And then, same thing with this. If this OH- comes in and attacks here, when this swings up and swings back down, it kicks out a carboxylate, an oxygen minus, which is able to resonate with a separate double bond O. If it were to kick this out, you'd have OCH3-, which isn't that great. It's an O-, which oxygen is electronegative, so that negative charge is kind of stable, but it doesn't have the resonance of this. And then in this case, you have a nitrogen minus, which is even worse because it doesn't have resonance. And between oxygen and nitrogen, oxygen is a lot more electronegative, so it's much more stable being negative than nitrogen. So that's why this trend is what it is. So now we're going to just translate this trend into the question they give you here. So let's look at structure 1 and see how does it compare to this list. This structure right here is a carbonyl with an oxygen and another carbonyl, which matches this. This is called an acid anhydride, by the way. And we saw that this, out of the other things we're reacting with, a nitrogen and an OET, this is the most reactive because it releases a carboxylate, an O- that can resonate. So 1 is definitely the most reactive. Now comparing nitrogen as a leaving group to oxygen as a leaving group and oxygen that doesn't have resonance like this one, the nitrogen is the worst leaving group because nitrogen, when it's negative, isn't as electronegative as oxygen and can't handle that negative charge as well. So choice 3 would be the least reactive because you don't want to kick that nitrogen out, whereas this, being a stable O- with resonance, is very willing to break that to be attacked. And so it goes 3, 2, 1, and then the answer on your answer key would be choice D.